Okay, so we are going to do 5.6 now, and this will be the first video where you see my face in the corner of your screen. It should make this video a whole lot more dynamic, not really, but it just is the way that we're going to do this, makes it a little bit more personal, things like that. So 5.6 is a pretty straightforward section. What we're going to be talking about is finding rational zeros, so it's very similar to what we've been doing. It's just a different way to approach it. And the first thing we're going to talk about is the rational zero theorem. But before that, let's talk about the objective. Use mathematical symbols to represent quantitative relationships and situations. That it probably doesn't make any sense to you, and I totally understand that. Sometimes it does, sometimes it doesn't. But let's just start with the rational zero theorem. Basically, in a nutshell, this is what this means. When you have a polynomial, what you can do is you can find all the factors of your leading coefficient. You can find all of the factors of your constant at the very end, and you can figure out what your possible zeros or rational zeros are going to be by setting up a fraction. The top of it will be the constant term, so your a to the 0, that'll be the p. The bottom will be the factors of your q, which is going to be your factors of your leading coefficient. So again, I'm going to say p is going to be factors of your constant. That would be on top. And then Q is the factors of the leading coefficient. I'm going to call it LC. And then that is going to give you your possible, not guaranteed, possible zeros. So let's explore that through an example. So it says list the possible rational zeros of f of x using the rational zero theorem. So what you see we have is we have x to the third plus 9x squared plus 23x plus 15. So basically what we're going to do is the leading coefficient here is 1. So we're going to write out the factors of our leading coefficient. But actually we're going to do the constant first. Factors of 15, and the possible factors are plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. I know all of you know how to find factors, so that shouldn't be an issue. Then we're also going to find the factors of 1, which is our leading coefficient. Well, the only factors there are plus or minus 1. So now when we write our possible rational zeros, we're just going to say possible zeros. We're going to just simply write fractions. The top is going to be the factors of 15, and the bottom is going to be the factors of 1. So since we have plus or minus 1 on the bottom only, all we're going to do here is we're going to have simple possible zeros of plus or minus 1 over 1, plus or minus 3 over 1, plus or minus 5 over 1, and plus or minus 15 over 1. So you can just rewrite those as plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. So those are what our possible rational zeros would be if we were actually solving this or trying to factor it, things like that. Okay, so basically what you're doing is you're taking the factors that you got from your constant, okay, these values, and just putting them over the possible factors that you get from your leading coefficient. Okay, so let's look at this in action. We're going to actually, on this one, try and find what our zeros are. So what we have is, we have find all real zeros and we have our function. So again, our constant at the end is 14. Our coefficient at the front is 1. So first let's list out the factors of 14. So that means we have plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. And then our other factors of 1, we already know those. Our factors of 1 are just plus or minus 1. So our possible zeros are just simply plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. So again, it's just these values right here because they're all going to be over 1. And it can be plus or minus. So here's what we're going to do. To figure out which ones are our zeros, we actually are going to use synthetic division. And I know this seems like it'll take long, but it doesn't take that long. We're just going to start testing things. So the first thing we're going to test is x equals positive 1. So when we use synthetic division, if you remember from the last section, we'll put 1 on the outside. We will put our coefficients 1, -8, positive 5, and 14 inside. And we're just going to do synthetic division. So bring down the 1. 1 times 1 is 1. -8 plus 1 is -7. 1 times -7 is -7. 5 plus -7 is -2. 1 times -2 is -2. 14 plus -2 is 12. So the point is, if this is going to be a 0, then this has to be 0 at the end. So we know that x equals 1 is not a 0. Okay, so we move on to the next one. Let's do x equals -1. So we're going to put -1 on the outside, and on the inside we still have our 1, -8, 5, and 14. Pen is messing up again. I apologize. Okay, so we bring down the 1. So 1 times -1 is -1. -8 plus -1 is -9. -1 times -9 is positive 9. 9 plus 5 is 14. -1 times 14 is -14. This is 0. Therefore, x equals -1 is one of our zeros. So here's what we do. Now that we know that -1 is one of our zeros, we know that one of our factors is going to be x plus 1, because if x equals -1 is one of our zeros, it would make this 0. And then what's left over is what we have here. So x squared minus 9x plus 14. So technically, we could keep doing this if we want to. We could then do the zeros. We could try +2, -2. We could try +7, -7. But we don't need to now, because now we have something that is a little bit more factorable. We can factor x squared minus 9x plus 14. And we do that just doing factoring like we normally do. Put an x there. And then we're looking for two things that will multiply to be 14 that add up to be -9, which is going to be -7 and -2. So we have our three factors now, our x plus 1, x minus 7, and x minus 2. Therefore, our zeros are x equals -1. Another mistake, my fault. X equals -1, x equals 7, and x equals 2. So all three of these are our zeros. And that is the point of this. Okay, so let's move on. Okay, so on the second problem, we're doing the same thing, but it's a little bit different now. It says when the leading coefficient of the polynomial is not 1. So right there, 48, we know we're going to have problems because we're going to end up with a lot of fractions. So we're going to draw a sketch of the graph using the graphing calculator to help us find the zeros. But what we're first going to do is the same thing that we did before, which is figure out the possible zeros that we can have. So we have to do the factors of 3, which are plus or minus 1 and plus or minus 3. And then we're going to do the factors of 48, which that list is long. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 16, plus or minus 24, and plus or minus 48. So the problem is now when we do our possible zeros, we have a very, very long list. And I'm going to write them out here. I know this is going to take some time. So what I'm going to do is, just to save time on our video, I'm going to pause the video and I'm going to write them all out. And then when the video plays again, you're going to see all the possible zeros written out. So you can go ahead and just pause it once you see that and then just write them down. Okay, back from our commercial break, you see that I've written out all the possible zeros so we didn't waste any time. But as you can see, what I did was I did 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 6, 1 over 8, etc. all the way down, and then 3 over 1, 3 over 2, 3 over 3, all the way down. So I get this is a lot of zeros. And we're not going to go through and check all of these using our synthetic division. What we're going to do is we're going to open up the calculator here. So we're going to use the calculator and we're going to estimate which ones we think it will be. So when I open up the calculator here, I've already put the equation in, and then I'm going to graph it. Now, the graph looks really narrow when you see it, so we need to change the window. So what we're going to do is we want to make the screen much wider here, so therefore we're going to make our x values be smaller. So I'm going to do -2, and I'm going to do +2. And I know you don't have a calculator in front of you, but this is just so you can kind of get the idea of it. So now when the graph goes, it's a little bit easier to see. So now what we're going to do is take the trace button, and I'm going to trace back to this point here. So I'm at -0.72, and then it goes to -0.76. So that looks like right around -0.75. So that means we're going to try -3/4, because that's what 0.75 would be, or -0.75. So we're going to try -3/4, and then we're going to go to our other one. This one might be a little bit more difficult because it's a weirder number. So 0.127, and we have 0.17. So again, you could check all of your fractions to see which one of those would work, but I'll tell you right now, we're going to check 1/6 and 1/8. That's what those are close to. And then the last one looks like it's right around 0.5, so we're going to check 1/2. So let's go back to this. So we're going to check -3/4, we said 1/6, 1/8, and 1/2. Now, understand, once we find one of these, this is going to be a whole lot easier. So same thing as what we did before, we are going to use synthetic division. We're going to start with x equals -3/4. So -3/4 into our synthetic division. So we have 48, 4, -20, and 3. So basically, we're just seeing if this is a perfect factor or not. So we bring down our 48. -3/4 times 48 is -36. Add these together is -32. -3/4 times -32 is +24. Add these together, we get a +4. -3/4 times 4 is a -3. Again, this messed up. So add those together, it's 0. Perfect. That means that x equals -3/4 is one of our zeros. So now what we're going to do is we're going to write out our factors. So we have x plus 3/4, and I know we're not supposed to write it like that, but we don't care. We're just trying to solve, times 48x squared minus 32x plus 4. So now we just need to factor this, and this is factorable. So what we're going to do first is bring out a 4. So it'll be 4 times 12x squared minus 8x plus 1. And now we just so now we're just factoring this right here. So the first thing that I'll try is 3x and 4x. And I'm going to use -1 on both these. Obviously, -1 times -1 is 1, but because this is negative, these are going to have to be negative. So we try this. 3x times -1 is -3. 4x times -1 is -4. -4 and -3 is -7, not -8. So we can't use this. So let's use different factors of 12. So we're going to do 6x and 2x. And again, they're going to be -1. And as you can see, as we do this, it will be 6x minus 1. When this will actually factor correctly, because -6 and -2 is -8. So now we have a factor here and two factors here. So what we need to do is solve each one of these. So solving these, we just set them equal to 0. 6x minus 1 equals 0. 6x equals 1. X equals 1/6. 2x minus 1 equals 0. 2x equals 1. X equals 1/2. So our three values are x equals -3/4, x equals 1/6, and x equals 1/2. We are done. Okay, bring questions to class. See you then.